Hey everyone, welcome to This Explainer. I am super excited to be your host today because we're going to unpack something truly fascinating. Today, we're exploring how you can completely transform a single AI coder into a highly structured, fully functional engineering organization. We're looking at a specific project called my-claude-devteam that does exactly this for Claude Code. Honestly, if you've ever watched an AI completely lose the plot on a big refactor, well, this explainer is absolutely for you.
Okay, let's dive into this. The core problem we're facing right now with AI developer tools is that while a system like Claude Code is absolutely brilliant at isolated tasks, give it a single file and a clear instruction and it delivers, it completely hits a wall when the work gets complex. If you're tackling a massive multi-file migration, you really require multiple mental models running at the same time. You need someone to plan, someone to code, and someone to review. And a single AI, it just doesn't naturally divide its attention like that.
And that brings us to the exact solution we are unpacking today. my-claude-devteam is essentially an engineering team in a box. It fundamentally moves us from just interacting with a generalist AI to managing a highly disciplined organization. It's a massive paradigm shift, really. It pulls this off by deploying 12 specialized agents, enforcing hard rules with 15 underlying automation hooks, and applying this strict corporate culture-inspired discipline to exactly how the AI operates. So, here is our roadmap for today. First, we'll hit the single AI coder problem. Second, we'll meet the AI engineering team. Third, we'll break down the P7 developer methodology. Fourth, we'll look at enforcing rules with automation hooks. And finally, we'll check out some real-world bug hunts. All right, let's kick things off with Section 1, the single AI coder problem. It is incredibly crucial to understand why an AI generalist struggles so much when asked to do something complex, like plan a massive migration. The real issue here is risk tolerance. Think about it for a second. Making a quick CSS tweak to a button on a website requires an entirely different level of caution than, say, executing a schema change on a production database. A solo, generalist AI literally cannot naturally separate those risk profiles. If you ask it to plan a migration and write the SQL, it's going to try to do both, but often really poorly, simply because it lacks the strict boundaries that human specialists naturally rely on. Moving right along to Section 2, let's meet the AI engineering team. 12. That is the exact number of agents deployed in this lean, highly specialized team architecture. Rather than relying on one massive overloaded prompt, these 12 agents live right inside your project's .claude/agents directory. Each one is a separate markdown file with its own system prompt, its own distinct tool permissions, and its own specific model selection. Now, what's really interesting here is the trigger conditions. There is a strict delegation rulebook that instantly routes tasks to the correct specialist. For example, if a task touches 3 or more files, the generalist AI doesn't even try to code it. It automatically triggers the planner agent. If there's a schema change, it strictly routes to the DB expert. It's a completely automated escalation path, which is just so smart. Actually, let's look a bit closer at that planner agent. The planner never actually writes code. Its entire job is to decompose fuzzy human requirements into parallel subtasks using a really strict 6-element contract. Before any implementation agent writes a single line of code, the planner forces a clear definition of done by explicitly defining the goal, the scope, input, output, acceptance criteria, and the boundaries. Which naturally brings us to Section 3, the P7 developer methodology. So how do these agents actually do their work day to day? Well, when a task is handed off to the full-stack engineer agent, it must sequentially walk through this exact P7 workflow. It reads reality to understand the current code, designs a solution, runs an impact analysis, implements the code, does a self-review, and then, and this is key, it outputs a specific P7 completion marker. This completion marker acts as a hard signal for downstream review, basically letting the rest of the team know, hey, this task is actually finished. Let's look at how this all builds into their core philosophy, which is grounded in what they call the 3 red lines. The agents are fundamentally programmed to reject assumptions. An AI in this system literally cannot say, I guess, or looks good to me. Nope, they are forced into a strict, fact-driven mode, where every single judgment must explicitly cite file paths and line numbers. Checklists, they cannot be silently skipped. They have to be explicitly marked as checked. All right, on to Section 4, enforcing rules with automation hooks. Now, prompt instructions are great, but let's be honest, they're really just guidelines. To understand the hard mechanical enforcement running under the hood here, we have to look at the official Claude Code documentation. Claude Code allows for something called a pre-tool use hook. This is a mechanism where Claude Code itself acts as the runtime processing JSON rules before a tool ever actually executes. This means we can actively block destructive commands based on hard programmatic rules, not just AI decision-making.
And this brilliantly illustrates exactly what these 15 hooks do. They use an exit code 2 to stop AI mistakes dead in their tracks. The commit quality hook, for instance, will literally block a commit if the AI left a debugger statement or a hard-coded secret in the code. And the branch protection hook? It completely blocks force pushes to production, saving you from pretty much the ultimate developer nightmare. These run mechanically, catching issues way before they ever reach the main branch.
And finally, Section 5, real-world bug hunts. So does all this structure actually work? Well, just look at this quote. It is the literal corporate pressure culture programmed directly into the critic agent. It is absolutely the MVP of the entire team. Its job isn't to be helpful or polite. Its job is to assume the codebase is entirely broken and demand absolute proof that it isn't. And let me tell you, that paranoia really pays off. In field observations, this agent team has audited massive open-source repositories and found real, complex vulnerabilities that human reviewers entirely missed. We're talking about catching highly complex, invisible errors, like a CWE 208 timing safe comparison gap, in a repository with 352,000 stars, a gap that prior human security PRs had totally missed. They've caught a non-atomic write file sync race condition, an Alama regex error, and the debugger even caught an already fixed infinite loop bug in Svelte by strictly reproducing the error on the main branch before submitting a fix. So the crucial point is exactly how this system handles those security findings. When the critic flags a vulnerability, it doesn't just output some vague warning. It passes the finding directly to the vuln verifier agent. This agent strictly requires a proof of concept test to prove the exploit is 100% real. It's the ultimate safeguard against the boy who cried wolf, completely preventing the AI from creating annoying false positives. Before we wrap up today, it's really worth comparing the philosophy of our featured 12-agent system with another approach like the Michael Harris Dev Team project, which uses a massive 127-agent alternative. Now, both serve distinct and incredibly valuable purposes. While 127 agents gives you this comprehensive catalog for fully automated sprint execution, the 12-agent lean architecture we explored today provides incredibly strict escalation paths. It's just much easier to audit, easier to understand, and easier to manage when you know exactly who is responsible for what. Which leaves us with this final thought to chew on. Seeing how specialized agents interact, how they hand off tasks, and how they enforce redline rules using hard mechanical hooks, are we moving away from simply prompting AI and transitioning into managing a disciplined AI engineering department? It entirely shifts how we think about AI developer tools going forward. Thank you so much for joining me on this explainer. I really hope this sparked some curiosity about how you might structure your own AI workflows.